Hello friends, today we shall begin a new chapter, carboxylic acids. Basically, carboxylic acids is a part of the chapter aldehydes, ketones and carboxylic acids, but because carboxylic acids show different properties when compared to aldehydes and ketones, we study them separately. So today we shall begin with carboxylic acids. The word carboxylic acid is derived from two functional groups. Carboxylic acids contain this functional group COOH. This functional group CO is called carbonyl and OH is called hydroxyl. When you combine these two, then it becomes carboxyl. So those organic compounds which contain carboxyl group in them, they are called carboxylic acids. Carboxylic acids are represented by the general formula RCOOH, where R is either alkyl group or aryl group. So these carboxylic acids are classified into two types based on nature of R group. If R is aliphatic, if R is an alkyl group, then we call them as aliphatic or aromatic if R is benzene ring. So based on the nature of R, that is general alkyl or aryl group, we have two classifications, either aliphatic carboxylic acid or aromatic carboxylic acids. Then the second type of classification is based on number of carboxyl groups. Based on number of carboxyl groups. If any carboxylic has got only one carboxyl group, then we call them as monocarboxylic acids. If they have two, then di. If they have three, then tri. So these are the two types of classifications. First is based on the nature of R group. If it is alkyl group, then such carboxylic acids are called aliphatic. If R is benzene ring, phenyl group, etc., then we call them as aromatic carboxylic acids. The second type of classification is based on the number of carboxylic groups they contain. If they contain only one, then monocarboxylic acid. If they contain two, dicarboxylic acid. And if a carboxylic acid is containing three carboxyl groups, then tricarboxylic acids. Also, the aliphatic carboxylic acids are also sometimes called fatty acids. You need to know what fatty acids are. Fatty acids are also carboxylic acids. But what type of carboxylic acids are called fatty acids? They are monocarboxylic. Monocarboxylic means those which contain only one carboxyl group, they are called fatty acids. Also, they should be aliphatic. Aliphatic monocarboxylic acids containing 12 to 18 carbon atoms. This is main condition. It should contain 12 to 18 carbon atoms and it should contain only one carboxyl group. Then they are called fatty acids. So fatty acids are aliphatic monocarboxylic acids which contain 12 to 18 carbon atoms in a straight chain. Means you can have this chain straight and it should contain how many? At least 12 and a maximum of 18 carbon atoms. For example, this chain which is containing 14 carbon atoms. So it is a fatty acid. Fatty acids are those which contain only one carboxyl group and it should be aliphatic, it should be long chain, it should contain only one carboxyl group, then they are fatty acids. Now after classification we have nomenclature of carboxylic acids. Let us study now nomenclature. You know there are two systems of naming an organic compound. One is common naming system, the other is IUPAC system. In common naming system, the names of few carboxylic acids are derived from their sources. Be clear, not all carboxylic acids names are derived from their sources. The names of few carboxylic acids are derived from their sources. Rest of them have their general names. For example, if this example CH3COOH, it is commonly known as acetic acid. Why is it called acetic acid? It is called acetic acid because in Latin acetum means vinegar. Acetic acid is obtained from vinegar, therefore it is called acetic acid. Then formic acid. Formic acid is called formic acid because same, formicus means red ants. It was for the first time extracted from red ants, therefore it is called formic acid. Similarly, you have other acids also, like say this example, it is butyric acid. Butyric acid is called butyric acid because butyrum, in Latin butyrum refers to butter. Okay, so the names of few carboxylic acids are derived from their sources, from where they are obtained, based on that names are given. Also, in carboxylic acids common naming system, the carboxyl group's adjacent carbon is labeled as alpha, next beta and then gamma. You need to remember this when there are more number of carbon atoms in the chain. Understood? But in IUPAC system, the carboxylic acids are named based on the number of carbon atoms they contain. The same rules follow. You should follow the longest chain rule, then sum of locants should be minimum, and then the functional group should be given least number, that is highest priority. So if this is the case, then I should begin numbering this compound from here, so that its name becomes butanoic acid. In IUPAC system, carboxylic acids are considered as derivatives of alkanes, wherein the last letter of alkane E is replaced by a suffix oic acid. Oic acid. So if this suffix is added to alkanes, then it becomes alkanoic acid. Alkanoic acid is the IUPAC name for carboxylic acid. Let us see some examples how they are named. Beginning with formic acid. The first example is formic acid. Common name is formic acid, but IUPAC name is, it contains only one carbon, therefore root word should be meth. Then all are single bonds, therefore ane. Since the last letter should be removed, I will remove this, and it is to be attached with suffix oic acid. So its name is methanoic acid. The second compound contains two carbons, therefore eth ane oic acid. Then the third compound for three carbons, CH3, CH2, COOH. It is called propionic acid. It is called propionic acid in common naming system. Propion, it was the first carboxylic acid to be discovered. Formic acid was first isolated from red ants, but the carboxylic acid to be discovered first was propionic acid. Then its IUPAC name is propanoic acid. Propanoic acid. Then fourth, four carbons, so butyric acid, since it is obtained from butter, and IUPAC name acid. Then the same 4 carbons now has got a branch, then it is called isobutyric acid. It is isobutyric acid. Then how do you name this in IUPAC system? In IUPAC system, begin numbering from the carboxyl carbon. It is to be numbered as 1 because it contains, this functional group contains carbon in it, so it should be numbered 1. Then 2-methyl, then propanoic acid, 2-methyl propanoic acid. Now all these are examples of aliphatic monocarboxylic acids. Let us see some more examples of carboxylic acids where they contain 2 carboxyl groups. After these, let us see other examples. 5 examples were over, now 6th example. COOH, COOH. In some books you will find this as COOH, COH. Both are same. Okay. Now this compound contains 2 carboxyl groups. Its common name is oxalic acid. Oxalic acid. You do not have to remember common names of any compound, but remember their IUPAC names. Since 2 carbons are there, therefore write eth. Both are bonded by a single bond, so ane. Since carboxyl group appears twice, so you need not write carboxylic acid, oic acid twice. What will you write? You will attach a suffix to oic acid. Whenever a functional group appears multiple times, then their names are not repeated. Instead, prefixes are attached like di if it has appeared twice. If it has appeared 3 times, then thrice, etc. So prefixes like di, tri, tetra, etc. are added before the name of the suffix. So what should I add now? Ethane dioic acid. You may ask, sir, in the last example, for example this one, you wrote the name as propanoic acid. Why didn't you write the name as propanoic acid? Here you have written ethane dioic acid. Here you did not write O. This is wrong name, this is correct name. See, if the functional group has appeared only once in the formula, then this E should be removed. E of the primary suffix should be removed. If the functional group appears more than once, then the last letter E of the primary suffix should be retained, should be kept and should not be removed. Understood? So its correct name is ethane dioic acid, where ethane ends with E. E should not be removed. Then, if this part is clear, then next, keep on introducing 1 carbon. Keep on introducing 1 carbon in them. This compound is called malonic acid. IUPAC name 3 carbons, therefore propane 1, 3. Begin counting from anywhere 1, 2, 3. Propane 1, 3 dioic acid. Then this time introduce 2 carbons. You can write this compound either in this fashion or else. Since CH2 has appeared twice, so you can write 2 times. This is also correct. Okay. So what could be the name of this compound? This compound is called succinic acid. It is called succinic acid. Try its IUPAC name. Its IUPAC name should be 4 carbons, therefore butane 1, 4 dioic acid. Butane 1,4 dioic acid. Then 2 carbons were there, now introduce 3 carbons, 3 methylene groups. Its name is glutaric acid. Glutaric acid. IUPAC name pentane 1,5 dioic acid. Then introduce 4 carbons. Introduce 4 carbons. Its common name is adipic acid. IUPAC name is hexane 1,6-dioic acid. Hexane 1,6-dioic acid. You will come across this name adipic acid in another chapter called polymers. Now, some teachers claim that you need not write these numbers. I cannot tell you whether it is appropriate or not, but according to me it is wrong to not write the numbers. Even if the numbers are not given, if they simply give you write the molecular formula of hexane dioic acid, you are supposed to understand that the carboxyl group always appears at the ends. They are terminal functional groups. So one carboxyl at one end and at the other end you have another carboxyl group. If they give you formula and ask you to write its IUPAC name, then compulsorily indicate their numbers. If in the books they have not given numbers, you are supposed to understand that the carboxyl group always appears at the ends. Then 10 examples are over. Now some more examples which are different. Now not dicarboxylic groups. If you have this example, this time you have 3 carboxyl groups. How do you number this compound? There is no common name for this compound. So if you count from this side 1, 2, 3, 4, 5, you will be leaving this functional group. So numbering of this compound is wrong. I believe I have taught you one such example in alcohols. So numbering is wrong. Begin numbering in such a way that all the functional groups, all the 3 carboxyl groups get equal preference. Since there is 3 carbon chain, propane 1, 2, 3. To all the 3 carbons you have 3 carboxyl groups. Therefore propane 1, 2, 3 tricarboxylic acid is the IUPAC name. Propane 1, 2, 3 tricarboxylic acid. 2 more examples and then this nomenclature shall be over. This time you say some aromatic compounds. Its common name is benzoic acid. Benzoic acid is now the accepted IUPAC name. So benzoic acid is accepted IUPAC name. If this is the case, then in IUPAC system you will number this as 1, 2, 3. 3 bromo benzoic acid. Whereas in common naming system, these positions are ortho, these positions are meta, and this is para. Therefore, it is metabromo benzaldehyde. Metabromo benzaldehyde. Then the last example. This is benzoic acid. What if there are 2 carboxyl groups? Then its common name is phthalic acid. Phthalic acid is accepted IUPAC name also. It is also accepted IUPAC name. Otherwise, benzene 1,2 dicarboxylic acid is also fine. If you do not remember the benzene 1,2 dicarboxylic acid name, writing phthalic acid is also fine. Once. Now when nomenclature is clear, we shall now see the methods of preparation, how carboxylic acids are prepared. You see the methods of preparation of carboxylic acids, chemical properties of alcohols, chemical properties of aldehydes and ketones, all of these are interrelated. So if you have studied there in alcohols, the chemical properties of alcohols will become the methods of preparation for carboxylic acids. Not all of them, one or two methods. See, the first method of preparation is by using alcohols and aldehydes. First method is by alcohols and aldehydes. In this method, you take any alcohol. If the alcohol RCH2OH is subjected to oxidation, in presence of oxidizing agents like alkaline KMNO4 or neutral KMNO4 or acidic KMNO4, in any form potassium permanganate is a good oxidizing agent, or else acidified potassium dichromate, or else chromic oxide, any of them you choose, they will oxidize a given alcohol to give you carboxylic acid. Now for this reaction to happen, you add 2 oxygen and eliminate water. Introduce these 2 oxygens inside. So you will have carboxylic acid and water. Try the same with specific examples, replacing this R by CH3 once, the second time by benzene ring. Then with an aldehyde, you need simply 1 oxygen to convert this into a carboxylic acid. So when alcohols, especially primary alcohols, when primary alcohols or aldehydes are oxidized, they will give you corresponding carboxylic acids. This is first method. Now let us see the second method. It is from alkyl benzenes. Second method is by alkyl benzene. The best example for alkyl benzene is toluene. If toluene is oxidized under same conditions, that is alkaline KMNO4, it will give you benzoic acid. How did this happen? See, it had 3H attached to it. Now what you need to do, you introduce 3 oxygens. How do you introduce? You need 2 oxygens for here. So 2 oxygens are added, it becomes carboxyl group. 2 more are left, they will go with the third oxygen in the form of water. Understood? So whenever toluene is oxidized in the presence of alkaline KMNO4 or else chromic oxide, it will give you corresponding carboxylic acid. Now if this is true, sir, what if I oxidize this compound, that is propyl benzene? Then also you will get benzoic acid. How does this happen? Always remember, in this reaction, the entire side chain, irrespective of its length, it can be 3 carbon chain or a 10 carbon chain, the entire side chain irrespective of its length gets oxidized to carboxyl group. Is that clear? Okay. Then this is second method, wherein alkyl benzenes can be oxidized to give you carboxylic acids. Then we have third method from nitriles and amides. Nitrile formula is RCN. You hydrolyze this in the presence of an acid. Add here O, here 2H, H2O. Then you will have RCONH2. You will get an amide. Further hydrolyze this under same conditions. Where will you break now? Here OH and here H. This time you will get carboxylic acid plus ammonia. Most often this third method is asked in the exam, like complete the equation. They will give you nitrile and the reagent, you are supposed to find out the product. If you carry out hydrolysis for a nitrile twice, then you will end up with carboxylic acid. Once hydrolysis gives you amides. So from nitriles or amides, by both the methods you will get carboxylic acids. Then fourth method is from Grignard reagents. You need to remember all these methods because they are required for conversions and even for multiple choice questions. So Grignard reagent formula is RMgX. When it is reacted with dry ice, you know what dry ice is? Dry ice is solid carbon dioxide. Solid carbon dioxide is called dry ice. Whenever Grignard reagents react with dry ice in the presence of dry ether, wherever Grignard reagents appear, dry ether is compulsory. Now how do you introduce carbon dioxide into Grignard reagent? See, R-COO. This much is carbon dioxide dash MgX. You get an adduct when Grignard reagents and dry ice react with each other. This adduct is further hydrolyzed under same conditions, that is by water and acid. Break here, H is given here, OH is given here. Therefore, RCOOH plus MgOHX. I am explaining only the general reactions. You need to practice each time R with once methyl group and the second time with benzene ring, because in the exam they may or may not ask you general equations, but they will ask you very specific examples. Okay. Try one example. If the same is done with CH3MgBr with carbon dioxide, what product is obtained? Then you will have CH3COOMgBr. Upon hydrolysis you will get CH3COOH plus MgOHBr. How do you represent this in statement form? Whenever Grignard reagents react with dry ice, they will give you corresponding adduct followed by hydrolysis giving rise to carboxylic acids. 4 methods are over. You have 2 more methods. The 5th method is by acyl halides. 5th method is by acyl halides. Acyl halides are also called acid halides. Acyl halides and anhydrides. All these are very simple, easier methods because they require only hydrolysis. See, like in nitriles, for hydrolysis of nitriles you will get carboxylic acid. If an amide is hydrolyzed, it will also give you carboxylic acid. Here acyl halide means RCOCl. If this is hydrolyzed, same conditions in acidic hydrolysis, break here, you add OH here, H here, then you will have RCOOH plus HCl. Very simple method. Simply hydrolysis of acyl halides or acid chlorides, they will give you carboxylic acid. If you have an anhydride, RCO, this is acid anhydride, its hydrolysis. You break bond here, add H here, OH here, RCOOH, RCOOH. So twice. Depending on the nature of these R, different products may also be obtained. Then 5 methods are over. You have one more method, that is from esters. What is general formula for esters? An ester is represented by general formula RCOOR. If you hydrolyze this under same conditions again by acid hydrolysis, break the bond here, out of water molecule you take H this side, OH this side. So you will have RCOOH plus ROH. You will get carboxylic acid and an alcohol. So how many methods did you study today? You studied 6 methods of preparation. The first method was by primary alcohols and aldehydes. Primary alcohols or aldehydes, both by oxidation will give you carboxylic acids. In the second method, which was from alkyl benzene, there is only one point to be noted. If benzene is having any side chain, irrespective of its length, whatever the length chain might be, it will get completely oxidized to give you carboxyl group. So benzoic acid should be the main product. Then the third method was from nitriles and amides. Whether it is a nitrile or an amide, both of them will, upon hydrolysis, give you carboxylic acids. Fourth method was from Grignard reagents. Grignard reagents are reacted with dry ice or solid carbon dioxide in the presence of dry ether, followed by hydrolysis to give you carboxylic acid. Fifth method is by acid chlorides and anhydrides. Whether acid chloride or acid anhydrides are hydrolyzed, they will give you carboxylic acids. The last sixth method is from esters, wherein esters upon hydrolysis will give you carboxylic acids and alcohols as byproduct. If these methods are clear, then in our next classes we shall study about physical properties and chemical properties of carboxylic acids. Thank you.